Alright, so we have 8 point charges on the corners on every corner of a cube, and we can use this diagram here to represent that. We want to know the total force felt on charge P from the force from all other 7 charges on this point P right here, this point. So this problem takes a bit of work, but it's really not too bad once you get the understanding of it. So what you need to know is you need to know how to make unit vectors, and then Coulomb's law, and from there you'll just do that 7 times over, and you should be able to solve the problem. I'm only going to do about 2 of the points, and then it gets redundant from there. Maybe I'll do 3. So let's start with this point O right here. I'll do it in red, and this is O. It's labeled O right here, and we're looking at the force of O on P. So the first thing we need to do is find a vector of OP. So OP is equal to point P minus point O. And this is a simple vector subtraction, or finding a vector by doing the difference of 2 points. And that would be A minus, this point is 0, 0, 0, this point is A. So it would be A minus 0, which is A minus 0, which is A minus 0, which is A. Simply a vector A. Now we need to find the magnitude of OP. And that's going to be the Pythagorean theorem, right? We use Pythagorean theorem to find magnitude A squared plus A squared plus A squared. And that would simplify to 3A squared. Square root of 3A squared. You could actually get it a little simpler, but I'll leave it like this because it makes it easier when you start doing the other stuff. So now we're going to take Coulomb's law, and we're going to find out Coulomb's law of. We're going to find Coulomb's law for the distance O to P, right? And then we're going to apply this unit vector, because the unit vector is going to end up being. Well, I'll just start it and show you what it's going to look like. So first, let's do Coulomb's law. F equals Q1. So what's Q1? Q1 is just Q. What's Q2? Q2 is also Q because it says P is also of charge Q, because all 8 charges of charge Q. So it's just going to be Q squared. Over 4 pi epsilon. We always have 4 pi epsilon. What is R? Well, our R is actually going to be the same as this OP magnitude right here, because that's really just the distance of this vector. So we can just use that, square root of 3A squared, and that'll be squared. And then we multiply it by OP over OP, over its magnitude. And this gives us the unit vector, because we're taking the direction and dividing it by its size. So it just leaves you with a scale of 1, because this is essentially a 1, but it gives us the direction in which it's going to end up. So that'll give us the force direction, the correct component of force, and everything like that. Or the direction, angle of force. Okay, so now let's plug in some of the stuff that we know. Still Q squared. This is 4 pi epsilon still. This square and that square root are going to cancel, so we can call this 3A squared. Sorry, my handwriting's getting a little messy right here. A little late at night. Times OP, which is A. And it's going to be all over. Man, I cannot draw straight today. What's going on? All over square root of 3A squared. Well, this A squared and that square root can become an A, right? So this is really going to cancel with these guys. Boom, boom, boom. And these are all going to be left over as 1. And this is just going to be a root 3. So it's going to end up being F equal to Q squared over 4 pi epsilon naught. Oh shoot, I can multiply that 3 in that Get that 3 and 4 to make it 12, right? So that'd be a 12. And this would be an a squared. And this would be a 1, 1, 1 over root 3. And that's basically as simplified as you can get it. And what you would do, because I don't believe this gives you a unit for a or anything like that. No, it just gives you the value a. So that's basically as far as you can get it simplified. And that's only one component. So that would be, let me label this correctly. This would be FOP. That's only one of the forces. You're going to have 7 total forces. So you have to do this 7 frickin' times. This problem sucks, dude. So let's go ahead and do one more just to show you the ropes of it. Which one do you guys want to do? Let's do, how about we do A? How's that sound? A? Do it in green. Oh, sorry, man. Come on, get out of there. Yeah, that's going to give us the direction. Something like that. Okay, so again, first thing we do is find the vector. Well, first let's find out what point A is. I forgot to, let me write that down here. A is equal to 0, 0, A. P is equal to 0, oh wait, whoops. P is equal to A, A, A. So, the AP vector, call it AP, this, kind of like AP in high school, right? I'm a nerd, sorry. A, 0. Then we find the magnitude again, which would be the same thing we did before. A squared plus A squared. This time it's going to be 2A squared as a magnitude. Now we have that, we just apply the force. Equals, and this is FAP. I should have been labeling it the last one, but it doesn't really. Same thing, Q squared, because all the charges are of Q. And for coulombs, there's always 2 charges you care about. 4 pi epsilon naught. R is going to be this AP right here. Square root of 2A squared squared times. Shoot, I already forgot what the vector looks like. A0. Okay, so A0. Take a sip of tea real quick. Over the square root of 2A squared. Now remember, all this is doing is just giving us the direction. Like, think of this right here. This right here is kind of like the size of the force, and this gives us the direction of the force. When you're dealing with 3-space forces and stuff, it's a lot easier to just use unit vectors. They do a lot better job than like actually trying to find components and shit like that. It's just really not necessary. So, all right. So back to this. Digressing a little bit. F equals P equals Q squared over. This is going to turn into a 2, so I'll throw an 8 there. 8 pi epsilon naught A squared. Oh wait. A. That'd just be A. Oh shit! I think I messed the other one up too. Did I mess that other one up? Let me look. Yeah, I did. That's not supposed to be an A squared. Or is it? Wait. Yeah, because that square root and that square root cancels. Yeah, it is supposed to be an A squared. So what the fuck is wrong with this one? Oh, I forgot to throw my square root right here. Alright, yeah. No, it looks good. Okay, so... Or I'm missing something, but regardless, let me put a squared right here. I think that's right. Yeah, because that's 2A squared. Yeah, looks right. I don't know what the hell I'm thinking. Okay, so... Again, these A's are going to cancel. Boom, boom. So it's going to be a 1, 1, 0 this time. 1, 1, 0. So notice there's no Z component in this one. And that's kind of what you're going to see. square root of 2. And that would be all of FAP. And then, shit. Let me do, you know what, let me just do one more. I'll do one more. Just to give you guys the correct idea. We'll do F here. This problem's really redundant and kind of annoying. I mean, I don't know if you guys know an easier way to do it, then please friggin' let me know. I'm definitely willing to know. Oh shit, I'm running out of room. Alright, so let me do this one over here. F. This is point F, not force. F equals, what was it, 0, 0A? P is still F, A. Oh shit, it was A00. Damn it. Come on, Justin. A00. Right? A00. Okay. So FP as a vector would be 0, A. FP as a magnitude would be 2A squared again. So actually, since we're going to have the same distance, let me think about this. Since we have the same distance, I believe this one will actually have the same exact... Oh yeah, it will. Yeah, it'll have the same exact distance as the green guy. So we can actually take the green problem, except for it's going to be, instead of 110, it'll be 001. So that's nice. It's a nice little trick you can use. Basically what I'm saying is it's going to sum out to the same way because it's the same exact distance away. It's just in a different direction. So it's going to be A squared. So this time it'll be 0, 1, 1. And it'll still be under square root of 2 there. So effectively now what you do is you have this guy, and remember this is only part of the problem. I didn't do the whole problem for you guys because it's just too damn long. It's not necessary. I'm only here to explain shit. I'm really not trying to solve your problems. I'm just trying to explain it, break it down. You can go to Chegg or some other shit to like really figure out the answer, check your solution or whatever. I'm just trying to give you like the logic behind it all. So you do FT is equal to FOP plus FAP plus FFP, which is equal to, if you want to start writing it out, I'll just write out, I don't feel like scrolling up. Actually, I guess what I can do is you can kind of do this. Take this, boom, copy that piece of shit, paste it, where'd it go? Paste it, oh, and of course it doesn't want to work for me, because I suck at this program. Okay, let's try it, I'm gonna try it one more time. Oh, that's what happened, I pasted it over there. C, Control V. Okay, oh, there you go. It worked. Holy moly, that was a pain in the ass. Well, I can't get any better than that. But then you, oh, come on. The point is, you get those problems, you get those things I just had. Damn it, those things not working. You get those points and just plug them in, man. It's not that fucking difficult. This thing wants to give me problems. All right, whatever. It's getting late. I'm getting annoyed. This one would be the one all the way up there, which I'm not going to go for again. This would be the one right here. Oh my god. So, this would be the one right here. This one right here. Where is... Please Please stop, please. Alright, I'm getting annoyed at my program. It's freezing up and stuff, so I'm going to stop recording, but I think I explained it decent enough. Hope you guys like that little breakdown I had there. Yeah, whatever. Thanks.